shaking. I love it when you go crazy. You take all my inhibitions. Baby, there's nothing holding me back. You take me places that tear up my reputation.
Good day everyone. Today we're going to talk about the applications of integration in the real world. In real life, integrations are used in various fields such as engineering, where engineers use integrals to find the shape of the building. While in math, there are many applications that we can use in real life, like to find the center of mass of an area having curve size. We can also find the area between two curves, as well as to find the area under a curve and the average value of a curve. While in physics, integrals are used to calculate the center of gravity, as well as the mass and momentum of inertia of vehicles and the velocity of a satellite at the time of placing it in orbit. So, as we can see, it's easier to see how integrals can be used in those fields. But what about some of the more abstract applications, like the average value, area between curves, arc length, and the surface area of revolution? So those are the applications that we are going to tackle about today. So by the end of this video, we are going to have a better understanding about how these concepts can be applied in the real world.
So, hello. Dito sa average value ay katulad lang din sa pagkuha ng mean. Halimbawa, dito sa video, ang 5 numbers ay pinag-add at i-divide sa 5 dahil 5 numbers lang sila, kaya ang average value dito ay 6. Sunod, dito sa graph, para makuha ang interval ng x is equals to 0 to x is equals to 10, ang value ng function dito sa interval ay 7. Dahil kahit saan i-test ang interval, ang height at distance between the function sa x to x-axis at 7, at sa paghahanap naman ng average value ay kailangan pag-add ang lahat ng value ng height. And gagawin lang din yung ginawa kanina na pinag-add yung 5 numbers and divide sa 5. Dito, sinasabi na average value of the interval is 7. Pero, paano kung mas complicated yung problem katulad dito? Paano natin mahanap ang average value ng interval is x is equals to 0 to x is equals to 4 pi? Maaari natin gawin ulit yung kanina and test randomly yung x para ma-estimate yung average. Pero syempre, mas gusto natin yung accurate value, and ito yung formula sa pagkuha ng function ng hindi 5,500 or 5,000 pero infinite value of x. Gagamitin natin itong formula sa pagkuha ng average value of a function sa interval is x is equals to a to x is equals to b. Kapag ginamit natin itong formula, ay kukuhain natin yung constant value and ang magiging function will be 0. If we draw a line, y is equals to 0 over top ng original function, or the average of the function over the interval. So, how can we apply this in real life? Given a function for temperature in terms of time, we could find the average temperature inside an oven during a given time period. Or given a function for growth over time, we could find the average yearly growth of a tree over a given time period. Or given a function of a water volume in terms of time, we could find the average volume of water that falls over a waterfall in a given time period.
Area between curves. So it is a very common application of calculus, and using this formula, we can find the area enclosed by two graphs just like this. So in higher function, or the graph that's above the other one, which is the f of x, and the lower function, which is the graph underneath it, is the g of x. Then we can also see here that we're finding the area under f of x all the way to the x-axis, and subtracting from that the area under g of x all the way to the x-axis. So when we do that, we're just left with the area between the curves in this portion. So in order to solve the area between the curves, we just need to find the points of intersection of the two curves and identify which function is higher and lower. Then we'll plug all pieces into the formula. But always remember that you just need to pick an x value between the points of intersection and plug that value into both functions to see which value is larger than the other, to find which function is higher and lower. And also remember that the larger the value, the higher the function is.
So how can we use this in the real world? So let's say for example that you are a farmer and kailangan mo hanapin yung area of your field in order to know how much fertilizer you are going to buy. And that will be a no problem if your field is a square or like rectangular shape like this, because in that case you will just take length times width to get the area. But what if your field is irregularly shaped like this? If you can find a function to model both sides of the parameter, you could use area between curves to find the area of the field.
Arc length. Paano nga ba natin malaman or mahanap ang length ng curve? Kapag ang function ay straight line at gusto nating hanapin ang haba ng interval between x equals to 0 to x equals to 10, ang length ay. Pero, paano natin mahanap ang haba ng linya kapag ganito naman ang itsura ng linya? Hindi natin to pwede basta idiretso at hanapin ang haba katulad nung nasa una. Pwede tayong mag-drawing ng straight line segments at ipag-a-add ang haba. Ito ay magiging madali pero time consuming at hindi pa ganun ka-accurate. Pag mas maraming line segment ang gagamitin, magiging mas accurate. Pero pag gusto natin ng accurate na value para sa arc length, kailangan natin gumamit ng infinite number ng line segments para masukat ang length. Kapag ginawa natin yon, ang ating formula sa arc length sa interval A to B ay ganito, and magagamit natin ito para mahanap ang haba ng curve. L equals integral of square root of 1 plus quantity of f prime of x raised to second power dx evaluated from A to B, or S equals integral of square root of 1 plus dy over dx raised to second power dx evaluated from A to B.
Papakita ko ngayon paano gamitin ang formula para masolve ang length of curve. Given na 1/3 quantity of x squared plus 2 is 3 halves between x equals to 0 and 1. Una, ita-derive natin yung given equation. 1/3 times 3 halves times quantity of x squared plus 2 is 3 halves minus 1 times 2x. Binaba natin itong exponent 3 over 2 and minus natin siya sa 1, and then na-derive natin na sa log na ito na 2x. Magiging 2x yan. Next is kung multiply na natin, magiging 1/2 quantity of x squared plus 2 raised to 1/2 2x. Next is ka-cancelin natin itong 2. Matitira na yung x. While magiging x quantity of x squared plus 2 raised to 1/2 squared, dahil gagamitin natin ito mamaya sa formula. F prime of x squared equals x squared quantity of x squared plus 2 and equals to x to the 4 plus 2x squared. And gamit ang formula na ito, solve natin ang length of curve. Substitute na natin sa ating formula, nakuha natin yung sagot sa f prime. integral of square root of x to the 4th power plus 2x squared plus 1 dx evaluate from 0 to 1. Gagawin natin is papactor out natin itong x to the 4th plus 2x squared plus 1. Magiging x squared plus 1 squared. Next is cancel na itong square root dahil dito. May 2 dito. May invisible 2 dito. Pwede magiging integral of x squared plus 1 dx evaluate from 0 to 1. Next is gagamit tayo ng sum and difference. Integral of x squared dx evaluate from 0 to 1 plus integral of 1 dx evaluate from 0 to 1. Ide-derive na natin yung dalawa. Yung x squared magiging x cubed over 3 tapos yung 1 dx magiging x na lang. So substitute natin yung value ng a and b. Una, substitute natin siya sa x cubed over 3. 1 cubed over 3 minus 0 over 3 plus next ng x 3 minus 0. 1 cubed over 3 minus 0 over 3 is equals to 1/3 and 3 minus 0 equals to 3. Pag-add natin yung dalawa, magiging 1 plus 3 over 3 at ang sagot is 4 over 3.
How could we apply arc length in real life? There are many real-world applications that involve arc length. If a rocket is launched along a parabolic path, we might want to know how far the rocket travels. Or, if a curve on a map represents a road, we might want to know how far we have to drive to reach our destination. But there is one good example of arc length. Building a bridge. Building bridges that connects two far places. Building a tower on each side of the water to hold up the bridge with cables that will connect the tower to the roadbed. With the help of arc length formula, you'll figure out on how long each cable should be used by knowing the right length before you install those cables to the bridge.
Now we are going to talk about surface area of revolution. We are all familiar in the word surface area of normal geometric shape like a cube or spheres. Surface area of revolution is generating by taking a function and revolving it around an axis. The degree of three-dimensional surface from the two-dimensional graph. Once we have three-dimensional figure, how do we find the surface area of that figure? Para masagot natin yung tanong, balikan natin yung arc length. To approximate arc length, gagamitin natin yung straight line of segment. At kapag nakuha na natin yon, i-rotate lang natin siya around the axis. Tapos, para makuha na natin yung approximation of three-dimensional figure. Kada segment, tinatawag silang frustum. Para mahanap natin yung surface area of one frustum, kailangan natin gamitin yung formula na ito. A is equals to 2 pi RL. So, kailangan lang natin i-multiply yung value ng frustum. Since L is the length of the frustum and nothing more than the arc length of the function that we rotated in the axis. So, we can replace L in this formula with the arc length formula we found before. Paiksi ito ng paiksi, pero padami ng padami din yung frustum approximate doon sa surface area. So, eventually, yung number ng frustum is magiging infinity. And we can prove that the radius represented by the function itself, and we get the integral formula of the surface area. So, lagi lang natin tatandaan na yung surface area formula ay nagbabago depende doon sa axis of rotation. Whether yung function natin is defined of y in terms of x or x in terms of y. So, itong table na to is pwede natin magamit para sa ating formula.
So, papaano natin ito magagamit sa totoong buhay? Let's say na ikaw ay isang artist na gumagawa ng lamps. Karamihan sa mga bases ng iyong dinesign ay elaborate. Gusto mong i-experiment ito sa iba't ibang hugis pero lagi mong iniisip ang halaga ng pintura na kakailanganin para i-coat ang base pagtapos mo itong mahihugis sa desired shape. Kung iikot mo ito pa kanan, maaari mong makuha ang function na magde-define sa curve ng base. Maaari mo ring i-rotate ang curve around sa axis ng base at gamitin ang surface area of revolution formula para makita ang surface area ng iyong 3-dimensional lamp base. Isipin din ang coating ng baseball bat, mga paan ng lamesa at punda. Makukuha ang cost ng mga ito kung gagamitin ang surface area of revolution formula.